Okay, let's unpack this.
Yeah, let's.
We spend our entire professional lives generating knowledge reports, spreadsheets, slide decks, and it's all, trapped.
Trapped inside productivity suites like Microsoft Office or Google Workspace.
Exactly. This is where enterprise knowledge lives. But what happens when those incredibly familiar, heavy binary file formats become the single biggest bottleneck preventing true, deep AI collaboration?
And that is the central question. Today, we are diving deep into a really remarkable proposal for something called MarkdownOffice.
And this isn't just adding AI features.
No, not at all. The platform aims to replace traditional Office software entirely by building what they call an LLM-first, Markdown-native Office suite.
The big idea here demands a massive conceptual shift from you, the listener. We have to stop thinking of a document as a closed box.
Right.
This system proposes treating documents, spreadsheets, slides, all of it, not as these opaque binary files that a machine can't really understand, but as deterministic, Git-friendly text artifacts.
And that foundation enables total auditability and truly AI-native collaboration, right down to the fundamental structural level.
It's about elevating enterprise knowledge management to the same level of rigor that we see in modern software development.
Basically, treating your documents like code.
So let's start by defining the pain. The status quo is our current suite of tools, Word, Excel, PowerPoint. And they are fundamentally constrained by what the proposal calls human-driven graphical user interfaces, or GUIs, and those heavy binary document formats.
They're designed for a human clicking a mouse.
Right. Not for a machine that's trying to reason about the content.
And that reliance on the GUI has created layers and layers of what they call legacy assumptions.
Technical debt, basically.
A huge amount. Think about it. Every time you try to use version control, like Git, on a docx file, you just see a blob of binary code.
It's useless. There's no easy way to see what changed, only that the file itself changed.
Exactly. And when two people edit that same binary Word document and try to merge their changes.
Oh, it's a disaster. You end up with two corrupted documents or a messy manual merge conflict that just loses all structural integrity.
That opaque file structure, that UI-coupled state, it severely limits auditability and maintainability. And that brings us to the core issue.
The AI problem.
The incredibly poor compatibility with large language models.
We've all seen the basic AI integrations by now, where you can ask a tool to summarize a document.
Sure, but the proposal argues that existing tools treat LLMs merely as auxiliary assistants. They're stuck on the outside looking in.
It's like treating the LLM as a highly advanced spell checker or maybe a clever formatting assistant.
Right, rather than a co-author capable of actual structural contribution. This results in what the authors call fragile integrations, because the LLM is constantly having to guess the intent behind that messy binary file structure.
So it limits the potential for deep automation.
It does, and it fails to recognize LLMs as first-class authors that can generate structure, not just paragraphs of text.
The system is still built around that, 1990s desktop paradigm of the mouse and keyboard?
It is. The MarkdownOffice philosophy says we need to build the system around the prompt and the API call first.
And then build the human interface on top of that foundation.
Exactly. The friction today is that you have to extract text from a binary file, send it to the LLM, get the edited text back, and then try to paste it back in without corrupting all the formatting.
It's a tedious, lossy process.
MarkdownOffice just eliminates those steps. The document source is the machine-readable text.
Okay, so here's where the vision for the solution gets really interesting.
Yeah.
MarkdownOffice proposes a system where the document is a structured, text-based artifact optimized for LLM interaction. It is fundamentally changing the operating environment.
And this is where they lay out their non-negotiable foundational goals. The first objective is very clear. Establish Markdown as the single source of truth.
For everything.
For everything. Narrative text, tables, graphs, slides, all of it.
Okay, but Markdown is great for simple text. I can just hear the skepticism from our listener right now. Markdown is simple by design, so how can it possibly handle a complex spreadsheet with dozens of sheets, nested formulas, conditional formatting? Doesn't that simplicity limit its utility?
That skepticism is valid, and it leads directly into the architectural challenges the project has to solve. Their 5 goals actually demand new technical foundations.
So if Markdown is the source,
then they have to figure out how to extend it into a domain-specific language, a DSL, that's capable of representing complex elements like slides and tables without reintroducing that hidden, opaque state that plagues binary files.
So instead of standard Markdown, the DSL would introduce structural metadata, sort of like XML or specialized HTML, but still human readable.
Precisely. It turns the document into structured data that an LLM can parse deterministically. And the second core goal builds right on top of this. Enable LLM-native document generation and editing.
Not through free text.
No, through structured operations, which are specific commands we'll get into.
And their target market is clearly the enterprise, which brings us to goals 3 and 4.
Right. This isn't just for a startup. They are demanding support for enterprise, self-hosting, full auditability, and serious compliance requirements.
Yeah.
Everything must be deterministic.
Deterministic, meaning if you feed the exact same Markdown source through the system twice, it has to produce the pixel-perfect same result.
The exact same result.
Okay.
Across every modality, document, spreadsheet, or presentation. No rendering surprises.
And finally, the 5th goal, which sort of ties it all together.
It does. Integrating seamlessly with Git-based collaboration and version control workflows.
Treating documents like code. So every single change is a line-by-line semantic diff.
Which brings us back to those key research questions. How do you redefine the spreadsheet? Currently, Excel is geographic, right?
Yeah.
The formula is tied to cell E4. But what happens if you add a column?
The dreaded break-in VLOOKUP that haunts corporate analysts globally.
Exactly. So MarkdownOffice proposes redefining spreadsheets as semantic data tables with formula DSLs. This eliminates those fragile, location-based cell references.
So instead of referencing data by its location,
You reference it conceptually. You don't say use the value in E4. You say use the value for the Q4 revenue metric.
that is a true aha moment.
It's infinitely easier for an LLM to reason about and maintain when the structure changes.
The LLM understands the data's meaning, not its address on a grid.
Now, to manage all this complexity, MarkdownOffice is envisioned as a compiler-like system.
Which is the fundamental departure from a traditional WYSIWG editor.
It is.
So we're talking about a transformation pipeline, much like how you write software code. You don't edit the final rendered program, you edit the source code that generates it.
Exactly. The human user might see a familiar graphical editor, a WYSIWG view, but underneath, the actual source document is pure, structured Markdown. The pipeline runs like this. Markdown source goes into a parser, which converts it into a machine-readable structure, an abstract syntax tree, or AST, and then into an intermediate representation, or IR.
Okay, let's pause on the IR. That sounds a little like jargon. If the Markdown is the source and the rendered view is the document I read, why do we need this middle step?
Think of the IR as the stable DNA or the blueprint of the document. The Markdown source is the human-written instruction set. The rendered PDF is the physical body.
And if an LLM tries to edit the visual body directly, things get messy.
Very messy. The IR is necessary because it's a unified schema, totally independent of any specific UI, and it represents all three modalities, document, table, and slide in, one consistent stable structure.
So the IR is the canonical machine-safe version of the document.
It is the only thing that gets edited by the system or the LLM. And before rendering, that IR model passes through the validation and policy engine.
This is where the enterprise control happens.
It is.
What kind of friction points is that validation engine targeting in an enterprise environment?
Oh, everything from structural correctness, making sure a table is correctly formed, to enterprise policy. For example, are all financial metrics sourced from the approved Q4 data table?
Or does this slide presentation adhere to corporate branding guidelines?
Exactly. It enforces these structural and policy constraints before the document is ever allowed to be rendered or committed to Git.
Which brings us to the true innovation here, the LLM-centric editing model. This feels like the real game changer for AI collaboration.
This is the central contribution. Instead of allowing an LLM to edit a raw blob of text, which could easily corrupt the DSL structure or introduce non-compliant data, the LLMs are required to emit specific, predefined, structured operations.
Can you give us an example? What does a structured operation look like compared to just asking the LLM to write a paragraph?
Sure. A traditional prompt might be, summarize the Q4 results and insert them into the report. The LLM just outputs a block of text. In MarkdownOffice, the LLM emits a validated operation, almost like a piece of code operation. Add table row, table. Q4 results forecast, row data. Metric, revenue, value.
All right.
$500.
It's a governed, precise action against that structured IR.
It is.
That structural control seems like the key to reliability. So why does this operation-based editing matter so much for auditability and for collaboration?
Well, it solves those critical issues we discussed earlier. First, it completely eliminates formatting and structural corruption because the LLM is only performing validated operations on the IR. It's not touching the presentation layer.
Okay.
Second, it drastically reduces merge conflicts in Git because your diff is comparing two semantic operations like add row versus edit row,
Yeah.
rather than two messy paragraphs of text.
And it essentially reframes the role of the AI.
Absolutely. The LLM moves from being this unruly free-form assistant to a controlled contributor within a deeply governed system. This enables true multi-agent collaboration where different specialized LLMs can work on different components at the same time,
One on the tables, one on the narrative.
all emitting distinct, deterministic, and traceable operations.
So let's look at the payoff for the enterprise user. What's the practical benefit of all this technical rigor?
I think the biggest practical gain is the unified document model. They're proposing a single-file, multimodal document model.
Meaning the narrative text, the structured data, and the presentation slides all coexist within one single Markdown artifact.
That's it.
I immediately see the value there. In most companies, a report is written in Word, the data is calculated in Excel, and the presentation is built in PowerPoint. And inevitably, someone manually copies and pastes a number, and then the original source data in the spreadsheet changes.
That is the definition of semantic drift. It's a common, insidious failure mode in corporate reporting, where the number in the report differs slightly from the Excel sheet it came from.
Or the graph in the presentation is based on old data.
Right. By having a single source of truth, that single Markdown artifact, that drift becomes structurally impossible.
And clearly, this system is built with high-security, regulated environments in mind.
Oh, absolutely. They're not just hoping companies adopt it. They're building in the necessary governance from the ground up.
So what are the key requirements they specify?
They specify support for self-hosted and air-gapped environments, which is essential for any high-security sector that can't use third-party cloud LLMs.
Right.
The platform is designed for scalable operations via Docker and Kubernetes, includes standard LDAP and SSO integration, and critically supports the use of internal or open-source LLM backends.
So complete control over the data and the generative tools.
That's the premise.
So wrapping up, what is the impact of moving from these opaque files to this transparent codified knowledge base?
I think they are contributing a new paradigm for AI-native productivity software, one that promises dramatically improved reliability and auditability.
And by relying on open specifications, it also reduces vendor lock-in.
It does. Ultimately, this project provides the first set of practical tooling for security-sensitive and regulated industries that desperately need deterministic, traceable knowledge systems.
The fundamental shift is away from these subjective UI-driven